equation. Now because they tell me that this 0.15 is on f of x, I can figure out what c is. Because in place of the x's, I can put the 1. In place of the f of x, which is a y value, I can put the 5. So now I can say 5 is equal to 1 squared plus 2 times 1 plus c. And then just doing the algebra solving for c. That's going to be 3. C is a 2. So the particular equation would be f of x equals x squared plus 2x, and instead of plus c, I know it was the constant value of 2. And it will have that derivative and have that point on the original graph. Okay, try another. Let's see, where's the derivative tough at? I'll go with 2 more. dy dx equals 2 times the quantity x plus 3. And I know that, oh, I don't like that notation. Let's go f of x, f prime of x equals that. And then I also know that f of 2 equals 25. So here they are giving you a point on the original function, just in function notation form instead of an ordered pair. But we'll get back to that. I still have to do the find the antiderivative in the general case with the plus c on it. So that means the original function. Alright, I see a set of parentheses here, so that's an inside to the first power. So forget about the 2 for now. You know your inside stays the same. It started out as a squared, 1 more than that. Now I check the derivative. The 2 would come down. I'd have this quantity to the 1 less power. The derivative inside, the derivative of x is 1. The derivative of 3 is 0. So it would have been just 1. I didn't need the plus 0 there. So, it's perfect. I don't have to put anything out there but a 1. So all I need is my plus c. There's no number needed because that 2 comes into play when I actually start to take the derivative. Alright, there's the general equation. General equation ends with the plus c. The particular, we've got to figure out what c is. So what this tells me is that x is 2. When x is 2, the function value, the y value, comes out 25. So now I can plug that back in. The function value is 25 when x is a 2. That allows me to figure out what the c is now. So that's going to be 5 squared, that's 25. So in this case, the c value is a 0. So I don't need to add a constant on, it's 0. So it's just the quantity x plus 3 squared, and that point will be on this graph. Okay, last one. Let's make it a trig one. Y prime equals negative sine x plus cosine x. And we know that the point 0, 1 is on the function y. Alright, so we find the general equation first. Trig functions, ask yourself, is there something that has negative sine x as its derivative? Oh, yeah, that's directly cosine. What has cosine as its derivative? Oh, that had to start out as sine. And I don't think we have to change anything. The derivative of cosine is negative sine. The derivative of sine is cosine. So all I need is my plus c. Now to figure out the c, to get the particular equation, when you solve for c, that's called particular equation. Putting in 0 for the x and 1 for the y. So 1, the cosine of 0 plus the sine of 1. If you need to use a calculator, go ahead, but cosine of 0 is 1. And the sine of 1, oh, did I put that wrong? Oh, yeah, that was supposed to be a 0. I was going to say, I don't know what the sine of 1 is. X is still a 0. The sine of 0 is 0. Jeez, let's see. Sine of 0 is 0. So C equals 0 again. So your particular equation is y equals cosine x plus sine x. Alright, and your assignment is going to be page 121, 1 through 23 odd, and then 24 and 25. Okay.